So this is Chapter 3, Conditional Statements and If-Else Statements. We're about to learn one of the biggest workhorses in the programming world, which are if and else statements. Here's a quick overview of what we're going to be going down. We're going to cover what a conditional statement is, what kind of operators and Boolean operators it uses, the if conditional check, the else if check, and the else check. We're also going to go over a few new Unity functions. The input key down will tell us how we can press keys on our keyboard to get the game to respond. We're going to go over the Instantiate function, and we're going to go over what transforms mean within Unity. So what's a conditional statement in the first place? Well, let's just see what we have on the slides here. It's a logical statement involving a comparison. The results are always true or false, yes or no, ones and zeros, Booleans. So let's look at some examples real quick. Okay, is a number 1 less than the number 2? Yes, that's true. 3 is greater than or equal to 3? Yes, that's also true, because is it greater than or equal to? Equal to being the operative word here. So this statement's true as well. Is a number 5 less than the number 3? No, number 5 is greater than number 3. And you can see that the answers to all three of these sentences are either yes or no's, or trues and falses. So how do we, warp or transform these logical sentences here into correct syntax for Unity to really understand? Well, we have conditional operators, okay? And all these conditional operators have very specific symbols. You'll notice that the equal to right here is denoted with 2 equal signs, because remember, 1 equal sign is assigning a variable a value. 2 equal sign tells Unity that, okay, we're not assigning a value to a variable, we're actually comparing the values of 2 different numbers. So if both left and right must be equal to be true, so let's look at some examples here. 10 equals 10. This is true. And notice the little if right here. That's a prelude to the if conditional check we'll go over in a second. So let's just read it out the way it's written. If 2 is equal to 5, then this is false. Remember, assignment is 1 equal sign, conditional check, 2 equal sign. Let's go over the next operator. We have not equal to, and that's denoted by an exclamation mark and then an equal sign. And it's just the exact opposite of the double equal sign, equal to. Basically, when you read exclamation mark equal sign, you read is not equal to. So let's look at some examples right here. If 10 is not equal to 10, then this is false, because 10 does equal 10. Notice how the statement doesn't make sense. If 10 is not equal to 10, then this statement will be false. But on the opposite side of things, we have if 2 is not equal to 5, well, then this is a true statement right here. Then we have the greater than sign. A lot of these symbols and logic statements will probably be familiar through previous math classes. There's nothing different going on here. So the greater than sign means the left must be greater than the right to be considered true. Alright, is 10 greater than 10? No, this is false. 10 is equal to 10. Is 2 greater than 5? No, false. 10 greater than 3? Yeah, this is true. And then we have the greater than or equal to sign. And the only thing you have to remember here is 10 is greater than or equal to 10, then this is true, because that equal sign means that the left can also be equal to the right number for the statement to be true. And then the less than and less than or equal to. Really basic stuff. I'm not going to go word for word off of this. If you want to check back at some of the examples just to refresh, you can come back to these slides and read through them. Then we have the not. We saw not in the last chapter. Basically, it just flips the value of any Boolean. Just want to reiterate that might be useful to you guys in the future here, especially with if and else statements. And then we have the Boolean operator AND, which is denoted by two ampersands. Those little weird G-looking AND symbols that we see sometimes. Basically, this is not really it's not really quite the same as an equal than or greater than sign. Instead, it acts as another qualifier for the statement to be true or false. So let's look at an example right here. Both the left and the right must be true for this to be true. So let's look. So if true and true, then this is true. If true and false, then this whole statement is false. I'll show some examples of the ampersand in a second. Just know that it basically means that both of the statements within the if statement must be true for it to be true. And here's some examples down here. Let's say we have two bools, and we name them my true bool and my false bool. You know, and the values, my true bool is going to be true, my false bool is going to be false. Let's look at this if statement right here. And remember, these are just two variables that we declared right here. If my true bool and my false bool, we have a true and a false, so this whole if statement will be false. If my true bool and my true bool, both of these variables are true, then this statement is true. And then on the other hand, we have the OR statement, denoted by two horizontal or vertical bars right here. You'll find that it's like shift backslash on your keyboard. Basically, either or must be true here. So it's a little bit different than AND. Basically, it means that only one of these statements or variables has to be true for the if statement, if check, to be true. So you see we have a true and true. This is true. We have a true and false. This is also true because it's either or. But two falses will always yield a false. And again, I'll go over some examples in a second, and we can see these used in action so you can kind of wrap your head around them. So now we know about the operators, and we know about the logic sentences. You know, is 5 greater than 3? Then yes, that's true. But how do we write that in Unity? How do we code that? What's the syntax here? Well, welcome to the if statement. This right here is an example of the exact syntax you'll need to use. It's noted by a if, parentheses, and then within this parentheses, you write whatever kind of conditional check you want. All right, and then you use this curly bracket, and anything inside the curly bracket is executed as long as this if statement is true. So let's get into Unity, and let's just do some quick if statements real quick. I got a brand new scene here. I got my own special layout, but all the windows are still present. So let's go into Assets. I'm going to create a quick C# script right here and call this if tests. All right, and I'm just going to hook this if test script up to the main camera. We're just going to be working with the console mainly right here, so let me increase the size of this. I'm going to double click my if test script, and we're just going to go in here and start seeing some examples of these if statements. Alright, we're just going to go ahead and delete this void update function because we're only going to be using the start. So, okay, let's go back to my slide, and here we see my syntax here. So how do we type this out from scratch? First, we use a lowercase if. Notice how if is automatically highlighted in cyan or light blue. And then I like to give it a space and use the parentheses. Then anything I write in this parentheses is what's going to be checked. So let's just do a simple is 1 equal to 1. Alright. I'm going to press enter. And then whichever way you decide you want to do your formatting, Unity will sometimes auto format for you. The default way Unity likes to do if statements is it'll put a curly bracket here. Excuse me, curly bracket, which is shift and bracket right there. The important thing is I just like to get my curly brackets lined up. Alright, notice how I have an if and then the parentheses And these two curly brackets, which look an awful like these curly brackets over here in this void start function. So anything in these curly brackets is going to be executed. So let's just do some debug.log prints. We'll just write something down. Or we'll say if the if statement is true. Alright, we'll hit Control S. And this is one of the most basic if statements you can really make. And we'll just minimize there. We'll hit Control S to save. And we'll press the play button. The if statement is true is printed within my console, because if this if statement equals true, then any code that follows it is executed in Unity. Okay? So let's say is 1 equals to 2. Alright, what we should see, let me clear this, is nothing written in the console. Yep, I press play, nothing's written here. Why is that? Because Unity went through this little if statement right here. It read 1 is equals to 2. Well, that's obviously not true. That's false. So any code written right here within these curly brackets of the if statement is totally skipped. Not regarded at all. Alright, but yet if we change this to the not equal to sign, 1 is not equal to 2, hit Control S and save, hit play on the console, the if statement is now true again. Alright. Now let's look at maybe using that ampersand. If 1 is equal to 2, and let's see, 3 is less than 5, what do you think will happen with this statement right here? We have 1 is not equal to 2, and we have another little conditional check here, and 3 is less than 5. Do you think it'll print this or skip this code? Let's find out. Let's clear this. This statement is true because both of these conditional checks right here are true. Alright? So why don't we say is 3 greater than 5? With this AND check right here, or this AND Boolean operator, what do you think is going to happen now? We'll hit clear on the console. We'll hit play, and nothing's printed. Because remember, both left and right must be true for the AND to be true, for this whole sentence to be, whole statement to be true. But yet, if we change this over to the double vertical lines, we see something different happen here. We'll hit clear. Now, the if statement is true. Because remember, with the double vertical lines, either left or right must be true. So let's change this up again. Let's say 1 is equal to 2, or 3 is less than 5. Both of these conditional checks right here are false. So what we should get is nothing printed to my console because the code will be skipped right here. Hit play. Nothing's printed. So that's a basic if statement right here. It is a huge driving force within the programming world because you can use this if statement to say if player 1 hits player 2, then we will run this code, which will be player 2 health is decreased. Obviously that syntax makes no sense, but you get the idea. Or we can say if player 2 is killed by enemy, then player 1 can revive player 2. Notice how I always say if. If this thing happens, then we do this code or we do this action. That is the basic driving force behind if statements. It's very powerful. So let's keep going with if statements and see how much more complex they can get. Alright, so we have the if statement. Now we have the else if statement. What is the else if? Well, when paired with an if, it does another check. Okay? So let's read this example. If this is false, we skip this code because it's false. Then Unity says, okay, then we have an else if statement, and this is true. Then we'll go ahead and do this code instead. So let's look at that in action inside the game engine. All right. Let's simplify this up a little bit. Let's say if 5 is less than 3, and we'll just do a debug.log, and we'll just write something like the if statement was true. Well, let's go ahead and make that true. And let's test out what we get here, just to say the if statement was true. Notice how our code's written here. Alright. But let's reverse that greater than sign and make it less than sign. And then let's write an else if. Same kind of syntax here. Else if 5 is greater than 3. This auto formatting is going crazy. What happened there was I tried to format my code the way I wanted to, and Unity just kind of messed it up. So I just went and hit Control Z to undo the auto formatting, and now my curly brackets are lined up just the way I want. Then we'll just do another debug.log, and we'll say the else if statement was true. Misspelled. Alright, and then we'll hit Control S. So what we have here is we have 5 is less than 3, which is false. Unity will see this as false. It'll skip this code, and then it'll see else if, and since 5 is greater than 3, it'll print this message instead. And let's see that in action. We'll hit play. The else if statement was true. Alright. Well, let's see. What's the difference between having an if statement here and just another if statement below it instead of an else if? Well, let's play around with some examples real quick. Let's say, for instance, that 2 is less than 3. And let's just turn that else if into another if statement. And then we'll say the second if statement and the first if statement. And let's hit play. The first if statement was true and the second if statement was true. Now let's throw in another else if statement below this second if statement. Else if, and let's just do something that's also true. 5 equals 5. Hit Control Z to undo that formatting. Pretty annoying. Alright, what do you think is going to be printed here? Obviously 2 is less than 3, so the first if statement will be printed. 5 is greater than 3, so the second if statement is also true, so this will be printed. What do you think is going to happen to this if else? Because this is also true. Well, let's press play and find out. We'll press play. Well, we get the same results as before. Why is that happening? Because it's important to note that Unity reads these sets of sentences as one block of if statements, basically. As soon as Unity sees an if, and it has a true statement here, 5 is greater than 3, then it will always execute this code. If else if comes after an if, then Unity says, well, this is an else if. The if above it was true, so we can skip this else if altogether. But the second we make the second if statement false, Unity will say, okay, this is false. I'm going to skip this code. Hey, wait, we have another else if right here. Let me go to it, and it should print this message right here. The first if statement was true, and the else if statement was true as well. So notice that anytime you start a new if statement, then Unity kind of sees that as its own new conditional check. The second you string together, and in fact formatting may help you here, if it helps you to read it a little bit easier like this, notice how this if statement is isolated, it's its own thing, and then this if statement else if is kind of all spaced together, and it's its own thing. If that makes any sense at all. The formatting will help you kind of read the if statements correctly in your head. And there's one more conditional check we got to do, and that is the else. That means if all ifs and all else ifs fail, we do the else. And you'll see this example right here. We have the if being false, code is skipped for this. The else if is false, again this code is skipped. And notice how the else right here has no parentheses. It doesn't need one because it's the when all else fails, we're going to do this else no matter what. So it doesn't need any conditional checks. It's just the backup plan for this if statement right here. So let's see that in action. All right, we'll get rid of this stuff. Else if, and let's write something false. So let's say if else if 1 is not equal to 1. Formatting got messed up. Control Z to undo the formatting. Let's write a debug.log. The else if statement was true. And then remember, we just write simply else. We need no parentheses. We'll just go ahead and start formatting just the way we like it. I'll hit Control Z to undo that auto format. And then we can just simply write debug.log. The else statement has been executed. And let's see this block of code in action. We'll hit Control S to save. We'll clear our console. We'll press play. The first if statement was true. Well, I guess 2 is less than 3. Well, let's say 2 is greater than 3. That'll be false. So 2 is greater than 3. That's false. So this code is skipped. 1 is not equal to 1. Let's see what happens there. The else statement has been executed. Why is that? Well, 2 is not greater than 3. 1 is equal to 1 instead of not equals. And since there's no other conditional checks here, and we have this else written here, else says, okay guys, everything else has failed. I'm going to do my code now, which is write this message right here. The else statement has been executed. Alright, so if we go back to our slides, we can see some examples right here. So we have an if statement that is true. We'll do this code because this if statement is true. We'll skip everything below here. We'll skip all these else ifs and all these else's because the first conditional check is true. Skip because the above if was true. We're done with all of these if statements. Notice how that's the case for all of these else's down here. So what if the first if is false? Then we'll go to the else if. Well, this is true. Notice how these else if, both of them are true. Well, it's only going to do the code of the first one that was true. Let's see an example of that in action. Let me get my formatting going. Else if, and let's say 10 is greater than 9. Else if statement was true. Alright. It's a little bit different than the code right here because we have a true, or we have a false right here. We have another false right here. And then finally this else if is true. So we'll get this message, the second else if statement was true. We'll hit play. The second else if statement was true. Well, let's make both these else if statements as true. And let's say 1 is equal to 1 and 10 is greater than 9. Which one of these messages is going to be printed here? Well, let's find out. The else if statement was true. Well, that doesn't tell us much. Let's change up the first else if message was true. Let's clear this. Press play. The first else if statement was true because as soon as Unity sees a conditional check that is true, it totally disregards everything after it. Okay? So Unity kind of reads it like a book, right? Left to right, top to down. And as soon as it sees that an if statement is true, it says, okay, everything's good. I got a true. I don't have to worry about the rest of this. Forget about it. Okay? Let's look at another tricky example, one I just showed you a second ago. If is false, the first else if is false. We'll skip again. We'll skip this because it's false again. We'll do this code because it's finally true. We'll just simply change this statement right here to 1 is not equal to 1, which is false. We'll hit clear. And the second else if statement was true. And of course, we've already known that if all of these are failing, then backup plan, the else statement, will do this code because else is always executed when all the ifs and the else ifs are false. So again, let's say 8 is greater than 9. That's false. We press play. The else statement has been executed because all this stuff has failed. Unity reads this. That's not true. 2 is not greater than 3. I'll skip that. Then I'll go to this next else if. 1 is not equal to 1. Well, that's obviously false. So I'm going to skip this. Let's try this next else if. 8 is greater than 9. I don't think so. I guess I have to skip this code again. Oh, else. Well, I guess if all else fails, then we'll do the else. It's the backup plan. And the else statement will always be executed. Alright, so that does it for conditional statements. And let's put those conditional if and else and all those crazy statements that we just learned, let's put them to use and let's make them do work for us. To do that, we have to learn some new Unity functions. The first one will be input.getKeyDown. We need to be able to interact with our game, and to do that, we all know we use control pads, mice, keyboards. Unity needs to know how to be able to recognize when any of those buttons are pressed. So, how do we do that? Well, there's a series of built-in functions in Unity. We've already seen one, which is the debug.log. Well, this is no different. We have an input function. It's the way for Unity to check if the user has pressed any keys. Whenever a key is pressed, it returns a true value. So anytime I have pressed the A and I'm checking for it, that conditional statement will be true when I press it. Okay? And here's the website for you to go to real quick. Let me bring that up for you and we can look at the documentation online. Alright, I'll just slide the page over here on the screen. Notice how we have our Unity documentation at docs.unity3d.com. You can just search right here for input.keydown. And Unity will search for any kind of information it has on these built-in functions that you have no idea how they work. So Unity's got a great bunch of documentation online. You can learn all about these. Again, it just kind of goes over what I was talking about. And it shows you some examples. Be sure to make sure you press C# for the code. There's JavaScript and Boo languages that it displays, but since we're working in C#, make sure we're in C# over here. And it'll show some examples of how these functions are used, so you can get a better idea of how to wrap your head around them. Alright? So, input.keydown will call this function. Now we need to know which key gets pressed. For that we have the key code, which again is documented online. And here we have a whole bunch of key codes right here. If you want to figure out what kind of button to specify when you do your input.getKeyDown, then here we go. All of these right here. So let's see input.keydown in action. And we can even go into my script that I was making before. And here's where void update will finally come in handy. Let's just get that back in here. We'll do our curly brackets. Get the formatting just like how I like it. Oh, syntax is already wrong. Whenever I put my cursor over this curly bracket, notice how it highlights this curly bracket up here? That basically means I need to get this curly bracket in line with this because void update is its own function. I need to get it as far away from this void start as possible. So what's the difference between void update and void start again? Well, void start says anything in this body right here will be executed as soon as I press play. Anything in void update will be executed every frame of your game. So using key inputs and start won't make sense because, well, if this code's only executed once and right when you press play and it's never checked again, Unity's not going to know to check for me pressing the mouse buttons or the keypads if it only checks it at the beginning of the game. But with a void update, every frame Unity can check and see if I'm pressing a key on the keyboard. So let's see how we can do this. And we're going to need to use an if statement right here. Because remember, the input.keydown gets a true value. Notice how we have the if statement right here. If input.keydown, and then we need to specify which code right here, key code A, then we'll do this code if the user presses the A key. Same thing up here. But notice one thing about the syntax. We have two sets of parentheses, yellow and green. The yellow parentheses correspond to the if statement, and the green parentheses corresponds to the input.keydown. Let's see that in action. If input.getKeyDown, alright, now we need to specify what key Unity needs to look for. We'll do key code colon. Alright, let's look at my syntax again. Key code colon. And then where's my list of key codes here? Well, I can find them on documentation, but most are pretty self-explanatory. So we wanted to test for the space bar. Well, the space key corresponds to the syntax of space. So I'll just write space. Close that parentheses off. Remember, when I have my cursor next to this parentheses, it'll show its twin. And then notice how I'll make a space and I'll make another parentheses. This will close off the parentheses for this if statement. Very important. A lot of syntax errors occur when you forget how your parentheses and your curly brackets are working. Just remember that whenever you put your cursor next to a parentheses or curly bracket, Unity will always show you its twin. And anytime you put your cursor next to a bracket and see how it's highlighting this curly bracket here, well, it's not in line with my void update. That doesn't make sense. That's why proper formatting is really helpful, because when my parentheses and curly brackets are in line and next to each other, I get a clear idea of where the twins for these exist. So right now we're just doing a check for input key down for the spacebar. And again, we'll just use the debug.log as an example, and we'll say spacebar has been pressed. We'll hit Control S. And remember, void update every frame. It'll check and see if I'm pressing that spacebar. So let's just go ahead and get rid of these conditional checks we were using in the example above. And we'll keep my start function around. Even though there's no code in it, that's okay. Nothing will be executed. We'll hit play. Now we have some syntax errors. So let's correct them together. It looks like I'm having a problem with the input.getKeyDown string. Does not contain a permanent key code. Well, there must be some kind of weird way where I'm typing this out. Let's see. Maybe it's that space. Maybe the white space is the problem. Let's look back at the documentation. Alright. Input.getKey. Well, here we go. That's what we needed to type. What's so different about what's written here to what we typed here? So I'm going to bring up my monodevelop window and put them right beside each other. Input.getKeyDown, key code, dot space. Notice how the colon was wrong? It looks like I just need to put a period there. And look at this. With the right kind of syntax, Unity displays this pop-up window, and look at all these options I can use. And I bet the space bar, yep, there's the space option right there. Well, of course, I already had space written down. So let's just write this from scratch, and we can see how that works. Key code, dot, and then look at all these different options that we can put in. And I'm going to scroll. I'm using the arrow buttons right now to scroll. And I'm going to scroll all the way down to space. I'm going to hit enter, and there we go. Notice my parentheses are matched up correctly. I'm going to hit Control S on the keyboard, and I'm going to hit play. Notice how we don't have anything in my console, and I'm going to hit the space bar. Space bar has been pressed. You can hear every time I tap the space bar that I get this message printed. And that if statement is what made it all possible. Because remember, every frame Unity reads this code. And every frame it says, okay, if the space bar is being pressed, then I'll print this out. So for every frame I did not press the space bar, this statement was false. So this code was skipped. But for the frames in which I pressed the spacebar, this code right here, this statement, equal true, which tells Unity to do this code. False, 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 60 frames per second, false, false, false. Spacebar, it was true on that frame, so I print the message right there. Alright, great. So let's take a look at this week's assignment now that we have some conditional checks and some input.keydowns under our belts. Let's see how we can make something cool with it all. So what I'm going to do is I'm going to go ahead and I'm going to bring in some assets that I'm going to link for you guys. And you're going to download them, and this is where your starting point is going to be. I'm going to go ahead and delete the script. Everything's empty, everything's clear. So I've already downloaded the assets for this chapter, so I'm going to right click on assets in our project window. I'll go to import package, I'll go to custom package, and I'll navigate to where I downloaded it, which was my desktop. I'll highlight chapter 03 assets, I'll hit the open button. It'll give me a preview of everything I want to import. I'll go ahead and do that. We'll give Unity a second to go ahead and import things. And now you'll see I have a whole folder hierarchy. And everything I need for this chapter's assignment will be included here. Alright? It includes materials, a mesh. I've already made a few prefabs for you guys. It's got the textures. So why don't we go ahead and we'll go to prefabs. I'm going to highlight medium fighter. I'm going to drag and drop it into my hierarchy. I'll hit F on the keyboard to zoom in on it. And here I have a nice little space fighter. And in this assignment, we're going to get this thing to fly around the screen and shoot bullets. We're going to use a 2D perspective, like for a game such as R-Type or Gradius, or any kind of 2D space shooter games you've seen on retro consoles. That's what we're going to be focusing on for this class, is making a 2D space shooter. And I'm going to be able to shoot bullets from this thing every time I press a button. So for basic flight controls, we want to say, well, let's use WASD or the arrow keys to move this guy around. If we highlight my fighter and I go ahead and move him around a little bit, keep your eye on the transform values over here. As I move him, see how these values change? These three values, X, Y, and Z, relate to the position of my ship. Alright, what do X, Y, and Z stand for? Well, if we look at our little cube over here, we can see that Y stands for the vertical movement of my ship. X stands for the horizontal movement of my ship. And Z corresponds to the depth. How far close to the camera and how deep into the scene the ship is located. Alright. So what I'm going to do is I'm going to go ahead and get the ship set up so it makes sense for a 2D game. Alright. Here we have my main camera. And you can see I have my little preview game screen right here. I'm going to take my fighter ship and I'm going to rotate it 90 degrees. And if we look at my inspector right here, notice how we see a value of 89.09, almost 90 degrees. What you can actually do is I'm going to select this Y value, hit 90, and now I know my ship is pointed at 90 degrees. And if we see my game window right here, it kind of looks like a 2D spaceflight game, right? If I move it manually. Great. It's a little dark though, so why don't we go ahead and go to Game Object, Light, just add a simple directional light. I'll position it above here, and since it's a positional light, I'll move it straight down. Wait, why are my arrows pointing that way? Oh, it's because I have the pivot set to local. If I set this to global, then my arrows will point at the global position. So I'll just move my light up out of the way so I don't accidentally select it. So I got my ship pointing to the right. I got it lit. Now we need to start figuring out how the heck am I going to get this moving. Well, first of all, I'm going to reset the values of my position to 0, 0, and 0. That's going to zero my ship out right in the center of the screen. The second thing I got to do is I got to learn how can I manipulate the values of this position, these positional values, with the keys on my keyboard. Well, there's a few statements we can do using the input.keyDown and if statements. So work with me right here. We're going to walk through this. You're going to be doing this on your own. The script is not going to be included in the assets. So just work with me here. I'm going to go to scripts. I'm going to create a new C# script. And I'm going to call this player mover. This is the script that I'm going to use to move my ship. And I'm going to click and drag and drop it right on medium fighter. And we'll see that we have the player mover script in my inspector. And if I double click player mover, we'll open up our monodevelop. And we've got a crash. Let me reopen it real quick. There we go. And now I have a fresh new script. I'm going to do a few cleanups on my formatting. Get my brackets lined up right on top of each other. Great. So what we're going to do with our player mover is we're going to use the void update function right here to check for player input every single frame to see which direction the player is pressing and update its position in our inspector on the transforms accordingly. Okay? So let's make a speed variable so we have direct control over how fast we move our ship. So let's make it a public variable. Let's call it float speed, semicolon. Alright, if I press Control S to save, select my medium fighter, I now have a speed property. Alright, and inside void update, we need to do a few lines of code. Let's use our newfound if statements to figure out what keys the player will be pressing. So if we do if input.get key down, and then we need to use a key code dot, well, let's do up. Let's do the first statement as up. I want to get my ship moving upwards. So I want to use W. And also I want to use the arrow keys. So we'll do a OR. So I'll use two vertical bars right here. Well, actually, let's close this off. Let's close this off. Do a W. Close that parentheses off. Now we'll do the OR check. Input dot get key down key code dot up arrow. There we go. All right, and then I'll close off the parentheses to my if statement. And let's tidy up the spacing a little bit of my code. I don't want it to be too spaced out. There we go. So the computer is going to say, or Unity is going to say, okay, for every frame I'm going to check if the W key is pressed or if the up arrow is pressed. Let's get this formatting set up. Control Z to undo that auto formatting. So what kind of code do we want to do right here? Well, for the time being, since we're not going to get too far into vectors and transform positions, the kind of code we're going to write is going to be transform.position. Because remember, we want to move the position right here. We see the transform class. We want to change the position inside the transform class. So we write transform.position is going to be increased plus equal by vector 3 dot up times my speed. Alright, so what does this mean? I'll hit Control S to save. That means anytime I press the W key right here or the up arrow, the following code is going to be executed. I'm going to look inside the transform class in my inspector here, Now I'm going to look at the position right here. And plus equals means I'm going to take the existing value of my position and add it to this new value right here. Vector3.up is Unity's way of saying, okay, within this screen right here, vector3, a vector means it means magnitude and relative position. So what kind of magnitude am I going to move in the up position, which is up? And we'll use a multiplier of speed so we can have direct control over how fast our ship's going to move. We'll hit Control S, and let's see what our ship's going to do. I'll hit play. You'll notice on my game screen right here, I'm pressing the W and the up arrow, and the ship's not moving. Why is that? Well, my speed's at 0. So let's make the speed 5 and hit play. Well, that doesn't make sense. It just flew off the screen. Let's make it 1. I press W. I'm holding it down, and it's just that's not what we want to do. What's going on here? Well, now's the time to introduce a new input.key. Notice how this says input.getKeyDown. That basically means one press of the key, and this will be executed. If we get rid of this down and just do get key, that means as long as I'm holding down W for every frame, this code will be executed. So I'm going to get rid of this get key down, hit Control S. I'm going to hit play, but my ship flew off the screen way too fast. Let's change this value to like 0.01 and see what happens. There we go. It's not very fast, but it's not flying off the screen anymore. And you can see my Y value increasing by 0.1 almost every single frame. And we can tweak the speed even more. Let's do 0.2. That's a little bit faster. I can go upwards now. So now what we need to do is I'm going to copy this if statement, and I'm going to use it as the basis for the rest of my code. And let's do down now. So instead of W, we're going to check for S, and instead of up arrow, we're going to check for down arrow. And instead of vector3 going up, you guessed it, what do you think we're going to change it up to? How about down? Control S, save it, and let's just keep doing that. We're going to do it for all 4 directions. Alright, S, instead we're going to check for A or left arrow. And instead of down, what do you think we're going to do? We're going to go left. So, yep, left, there we go. And let's do one more check. We're going to, instead of S, we're going to go do D. Instead of down arrow, we're going to go right arrow, not right alt arrow, just right arrow, you're crazy. And we're going to go right. These 4 if statements right here should give me the ability to adjust my position of my plane in the direction of these vectors, up, down, left, and right, times however fast I want to go, every frame. So you'll notice I'm using the arrow keys. I can now fly left, right, up, and down on my plane. Awesome. So there we go. So the video hiccuped a little bit, and I think we're back to where we were when it hiccuped. Sorry if I'm repeating something real quick, but you know how video editing goes sometimes. So what we got going on right now is we have code in here that can make our ship go upwards. If we press play, We can see that my ship is going up. What we need to do is we need to do 3 more if statements to check for every direction in which the ship can travel. So I'm just going to copy and paste this real quick. And let's check for the ship going downwards. So let's do key code S or key code down arrow. And we're going to change the vector 3 value to down. We're going to do the same for the left movement, which is denoted by either A or left arrow. And you guessed it, we're going to change the vector value 3 to left. Control V, I'm just copying the same statement over and over again. We'll check for D or right arrow, and we'll change this vector 3 value to right. We'll hit Control S to save, and let's test this out. My ship can now move in all 4 directions. 8 directions if you count holding down 2 keys at the same time. Very similar to what you'll find in a lot of video games. I can even select my ship and change the value of my speed to make it go slower if I want. So at 0.05, my ship moves slower. And you'll notice that the values in the X and Y are changing, but no other values are. That's because these vector 3 values relate to the X and Y axis in our position. Up, down, left, and right. Up and down relates to the Y axis. Left and right relates to the X axis. So now I can move my ship around, no problem. I can change its speed value to make it go fast or slow. And the next thing we're going to do is we're going to see how we can get bullets firing out of my ship. So I've included a prefab of bullet right here. Let's go ahead and move the ship out of the way. Let's see what this bullet does. Let me grab the bullet prefab right here. We'll slide it into the hierarchy. And if I press play, let's see what the bullet does as soon as I press play. It moves. Let's see that bullet move again. Boom. It flew to the right. If we press play, the bullet's set up to move to the right, but you'll notice that the way I have the bullet scripted, it finds the position of the plane, then shoots to the right out of the plane. Boom, to the right. Press play again, shoots to the right. You won't have to code any of the script for the bullet, but I'm going to bring it up anyway and show you what's going on with it real quick. Alright, this is the bullet script I have to get it flying to the right and for it to find the position of the player. I have a few variables described right here. I have a public float for the bullet speed. I have a float for how long the bullet will last in our game. And I have a private game object variable for where the bullet will spawn when it is fired. In my void start function, I need to do 3 things. First, I need to assign the value of the shot spawn game object variable I declared right here. And to do this, we're going to use a GameObject.find function, and it's going to find the name of our ship as written in my hierarchy. So shot spawn will now equal medium fighter prefab. And from there, I can change the transform or the position of the bullet to equal the exact same position of shot spawn, which now equals my medium fighter. I also am going to start a destroy function that destroys this game object, the bullet, after a certain amount of time, which is 5 seconds. And then for every frame, I'm going to update the position of my bullet with this line of code right here. The transform.translate, we're going to do a vector3 right times the bullet speed times the amount of time that it takes, the amount of time it ticks throughout the game engine. So this line of code right here will move the bullet to the right. You don't really need to worry about this. I've already coded it up for you. We're not going to get into the specifics of too much of what's going on here. I just wanted to give you a preview of some of the logic behind different kinds of things you can do inside the game engine. So that's just basically how the bullet works. So when I press play, the bullet will warp to the plane and shoot to the right. If I move my ship down here and back a little bit, the bullet will find the position of the plane here and then move forward to the right. There we go. I can even change the speed of my bullet to, say, 5, and I can press play, and we can see the bullet behave a little bit easier. And notice how the bullet disappeared after 5 seconds. Let's watch that again. 101, 2, 3, 4, 5. There we go. 5 ticks within the game engine. So how do we get the player to shoot this bullet every time we press the space bar? Well, why don't we go ahead and delete this bullet out of our hierarchy. Let's get our plane back at 0, 0, right in the center of the screen. And what we're going to have to do is we're going to have to make some new lines of code. And let's do it within our player mover script right here. I'm going to double click that again. And we have a void update. Here are all of our movement statements. So let's skip a little bit. And now we want to have an if statement that says if input dot get key, and this use key down for every once per key press. And let's do key code dot spacebar. This is going to tell Unity every time I press the spacebar. Let me set up my formatting a little bit. Oh, we have a syntax error coming up here. I wonder why. Oh, I didn't close off parentheses for this if statement. Here's the parentheses for the key code, and there's the parentheses for my if statement. So now I want to tell Unity, every time I press the spacebar, I want it to spawn a bullet inside my game scene. And when the bullet spawns, it'll execute the code you saw earlier, in which it finds the position of the plane and shoots out to the right. To do this, we're going to use the Instantiate function inside of Unity. Basically, Instantiate, it makes a copy of any object, kind of like how you would duplicate it. It duplicates all the scripts and the behaviors on the object. It takes 3 parameters, basically 3 different settings or attributes. Basically, it says it needs to know which object it wants to clone. It needs to know the position of this new cloned object. It needs to know the rotation of this new cloned object. And here's an example for the Instantiate. We have object to clone, comma, its position, comma, its rotation. And here's an example right here. Here I declare a variable of type public, or a public variable of type GameObject, and I name it bullet to clone. I'll call the Instantiate function, and here we have bullet to clones being what I want to clone or instantiate. And here I have transform.position, transform.rotation. You can just leave it at bullet to clone and close that off. And I'll show an example of that real quick. So let's get the code in here. So underneath my float, I need to make a new public variable of type GameObject, and let's call it bullet. I'll hit Control S to save. Now let's look and see what my medium fighter has under my player mover script. Let's hide all these other properties right here. I now have speed, and I now have bullet right here. Notice how bullet, instead of it accepting a numeric value, It has none. There's no game object assigned to this. What I'm going to do is I'm going to go to my prefabs folder. I'm going to grab my bullet prefab, and I'm going to drag and drop it right there. And now I've basically assigned the variable bullet to be this bullet prefab. The same bullet that automatically shot out every time I pressed play. So now with that assigned and my bullet variable declared, I can simply just type instantiate bullet semicolon. So basically Unity is saying every time it sees me press the space bar, it's going to instantiate this bullet, and since the bullet already flies out to the right, we don't need to do anything else. So I'll press play, I'll move my ship around, and every time I press the space bar, I can shoot my bullet. And that is a basic way to get your ship firing. And it all depends on the predetermined behaviors of my bullet that I already have made in this prefab right here. In the future, we'll learn how we can roll our own bullet script. We can learn on our own how we can get things to move and how to find different game objects to match positions. But for right now, we just mainly want to focus on input.keyDown to fire some bullets. So at this point in the assignment, you should have your plane moving, and you should be able to fire your bullet inside the player mover. All right. So there's a few cool things we'll be able to do now that we can fire bullets. We can now make an ammo counter system. We can now have it set up where every time we fire our gun, it decreases the amount of bullets we have. And we can even set it to when we run out of bullets, we can't shoot anymore. And that leads us to where our assignment is going to come to. So here are the parameters for this week's assignment. We've already gone over how to create a player mover script, 4 if statements that adjust the X and Y position of the fighter plane. We've already gone over how we can create the ability for the plane to fire, but we're going to create a separate script for firing. So if we go over to scripts, we can see I have let me get rid of advanced, a player mover script and a player fire script. Both of these scripts will be attached to your plane. So here we have my player mover script, and here we have my player fire script. You'll notice that I have my bullet prefab assigned to my player fire script, and I have an ammo count, an integer-based ammo count, right here, declared, a public ammo count. Every time I press the space bar, the player is going to fire a bullet, and the ammo count will decrease by 1. When the ammo count drops to 3 bullets, the debug.log will display low ammo. So the console window will tell me I'm getting low ammo. When the ammo count drops to 0 bullets, I can no longer fire my gun, and I'll get a message that displays no ammo left in my chamber. So let's see this in action. Keep your eye on the console window here. I press play. I can move my ship around. I press spacebar, and notice how my ammo count drops every time I fire. Alright, it's at 4. So when I'm at 3, now when I press the spacebar, I get a low ammo warning. I have 2 bullets left. Low ammo. Low ammo. Now I have no ammo, and I can no longer fire my gun because ammo count is at 0. Alright, so how do we go about making this kind of if-else logic? It's all about the if statements with the ammo count. Well, I'm going to go ahead and create a new C# script and show you some of tricks we can use. We'll call this test. We'll clear this out. One thing you may be that may help you in this assignment is nesting your if statements. So what does that mean? Well, in my void update, I can write if input dot get key down, and then we use the key code dot space. Remember, 2 sets of parentheses here. I'll do the formatting. So here we have a if statement when I press the key bar. Well, what happens if every time I press the space bar, I want to check for 2 different things? Let's say, for instance, I want to check if 1 is greater than 0. Let's make a little message here. 1 is greater than 0. And then I can have an else if nested right here. 0 is less than 1. Zero is less than 1. You'll notice how I have a parent if statement, and within this if statement I have a whole new set of if statements here. So every time I press the space bar right here, it's going to check for these new if statements. So let's see that in action. Let's take my test, put it on my main camera. We'll press play. 1 is greater than 0. Well, what if this turns out to be false? What if 1 is said to be less than 0? Well, notice how when I press spacebar, 0 is less than 1, and that's what displays in the else if. So when you're trying to manage your ammo count, it may be helpful to have a parent if statement here at the very top that says, okay, I just want to check for the spacebar. And then you can nest these other if statements within the spacebar check, and then you can manage your ammo count with your ifs, ifs, and else's to manage decreasing your ammo count variable, controlling whether or not you can fire the weapon, and displaying your low ammo or no ammo counts. And that's where you're going to have to figure this out. That's where the challenge and the if statements will come in, give you good practice on using the logic while making something practical, such as a player ammo count manager for a spaceship game. All right, hopefully this answers any questions. Appreciate you sitting through this lecture. If you have any questions at all about what's going on here, email me, comment, all that good stuff, and I'll get back to you and try to break it down a little bit more for you. If statements are kind of hard to wrap your head around when you first learn about them, but once you do, you'll find out that you'll be able to do a lot of powerful things inside the programming world. And in this case, we can already see if statements allow us to move our ship, and if statements allow us to manage our ammo count for our ship. All right, so again, any questions, just get back to me, and happy coding.